Alright, now we're going to do one exercise from the homework problems. We're going to do number 6 on page 472. Alright, it says, as part of the National Health and Nutrition Examination Survey conducted by the Department of Health and Human Services, self-reported heights and measured heights were obtained for males aged 12 to 16 listed below. So we need to enter all of these values into list 1 and list 2 of our calculator. Alright, I've got my values in list 1 and list 2 of the calculator. So what I want to do now is subtract list 2 from list 1. So second 1 minus second 2, second 2, hit enter, and it subtracted those two lists. What we want to do is now store those values in list 3. So store in list 3. Alright, so now our values are stored in list 3. These are the values from problem number 6. So we have all our values stored in list 3. We did list 1 minus list 2 and stored them in list 3. So now we want to test the claim that there is a difference between the heights, so that the mean difference is not equal to 0. If there's a difference between the heights, that means the difference is not equal to 0 if there is a difference. We're using a 0.05 significance level, and to test the claim we're going to use the t-test and data. Going to use the data that we've now stored in list 3. So we hit stat, test, t-test, and we're going to use the data values in list 3. Our alternative hypothesis was our original claim. Null hypothesis would be that the difference is equal to 0, meaning that there is no difference. This is our null hypothesis. So we have not equal to highlighted, hit calculate. Our test statistic is negative 0.98. T is negative 0.98. The p-value is 0.346. 0.346, yes. And we want to compare that to our significance level. It is not less than our significance level, so we failed to reject the null hypothesis. So now we can draw our formal conclusion. The formal conclusion is we should have there is not, since we failed to reject, sufficient evidence to our original claim is the alternative hypothesis. So support the claim that the mean difference is not equal to 0. So there is a difference between the two means. Critical value, we're going to use t interval. So we go to t interval, we hit stat, test, t interval, and we're going to use the data in list 3. And the confidence level that we're using, we're trying to find the critical value. So actually let's do this. We have to construct the confidence interval in part B of this problem, the 95% confidence interval. So we're going to do that first so that we can we don't have to because we're just using the list. So let's go over here to go back up to stats. We're going to find the critical value first. Alright, the sample mean, we should have 0 for the sample mean. For the sample standard deviation, it should be the square root of the sample size. The sample size of number 6, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 values. So the square root of 12. And the confidence level, alright, is two-tailed, so we should use 1 minus alpha, which it would be 0.95. And we're going to have positive and negative 2.20. Positive and negative 2.20. And now for the confidence interval, we're going to construct a 95% confidence interval. So we go back to t interval, except now we're going to use the data instead of the statistics. So we go to stat, test, t interval. We're going to use the data values in list 3. We're constructing the 95% confidence interval. So that should be 0.95. Hit enter. Negative 3 point. It should be one place to the right of the data values. So the second data values go to the tenths place. We're going to go to the hundredths place. Negative 3.24. To 1.24. We're 95% confident that the interval from negative 3.24 to 1.24 contains the true difference between the two population means. Alright, all done.